Okay, quiz 2. You send a yardstick to a local lab for calibration, asking that the procedure be repeated 3 times. They report the following values. If you send the yardstick back for a 4th calibration, you would expect 36 inches, give or take how much? Okay, give or take how much, that's asking for the standard deviation. In later chapters, it would be asking for the standard error. But right now, we're not given information about, yes, we are given how many samples, but we're not given a large number of samples, so we can't calculate our standard error, just a standard deviation. So all we need to do is find the standard deviation of this list. So in list 1, we're going to type this in. Help if I don't write it backwards. Okay, so stat edit. Let's clear the list that's currently there. And we had 35.96. 36.01, 36.03. So we've got our list typed in, and then we just go into stat, calc, 1-bar stats, and it looks like looks like I missed a decimal in there, so let's go back. Yep, right there. 36.01. Okay, so it told us the average was 36. We see that. X bar is 36. The standard deviation is 0.029, so we're going to say 0.03. There we go. For a representative sample of cars, would the correlation between the age of the car and its value be positive or negative? As the car gets older, so here's 1 year, 2 years old, 3 years old, 10 years old. As the car gets older, its value decreases. So this is like $20,000, $15,000, $10,000, so on. As the car gets older, the worth of that car decreases, so it's negative. Question 4. Okay, this is one that a lot of people missed, actually. Which of the following is a scatter diagram for a study of IQs of husbands and wives, for which husbands have an average of 100 with a standard deviation of 15, and same thing for the wives. Okay, so for this, wow, let me try making that a little bit straighter. Okay, here's 100 for husbands, 100 for wives. The middle of our football is going to be that. And then our standard deviation for both is 15. What we're creating is a football shape. The football needs to go out 2 standard deviations each direction. So from here to here, it needs to be 2 standard deviations. Well, 2 times 15 is 30. So this needs to be 130. And this needs to be 70. 100 plus 30 is 130. 100 minus 30 is 70. And you need to do the same thing this way. The end of the football down here is 70. Top of the football up here is 130. So we can match looks like the one that matches is D. Just looking at the numbers. In a certain class, midterm scores average out to 70 with a standard deviation of 10. And the final is the same. The average, so the average for the X and the SD for the X, average for the Y, SD for the Y. The correlation is 0.85. Okay, so we're given a 5-number summary. Estimate the average final score for the student whose midterm score was 80 using the 4-step method. Okay, it's been a long time since you've done this probably. The 4-step method, you start with step 1, changing the score you're given to a z-score. So z-score, and we're dealing with the x's because it's the midterm. The z-score for x is 80 minus a given average of 70 over a given standard deviation of 10. That's 1. Step 2 is to multiply that by the correlation coefficient. Step 3 is to multiply that number by the standard deviation for y. So what this means is somebody who scored 1 standard deviations above average on the X, we'd expect them to score 0.85 standard deviations above average for Y, which is, 8.5 points. So now we're just going to take the average for Y and add 8.5. So it's 78.5 points. You can also do this using the y equals mx plus b equation, where you figure out the slope, r times sd of y over sd of x, figure out what the intercept is, and there's a formula for that on our formula sheet. Plug each of those in, and then plug 80 in for x. So you've got 2 options to get there. Number 6, the scatter diagram below has a solid line and a dashed line. Okay, so it's on this quiz. We covered this problem in the notes, and then we also covered it on the exam, and yet some people still missed it on the exam, even though it was open book. That's fine. Say which is the SD line and which is the regression line. Okay, the SD line is always steeper than the regression line. So the SD line is the solid one. The regression line is the dashed line. And the reason for that is our slopes. The slope for the SD line is simply SD of y over SD of x. For regression, it's r times SD of y over SD of x. And remember, r is always a number in between 1 and -1. And so if you multiply by 0.8, this number here becomes smaller than just plain old SD of y over SD of x. Smaller slope means less steep. So the SD line is the solid line, dashed is the regression. The regression line always goes through the point of averages and has a slope of, okay, that slope is on our formula sheet. I also just wrote it down right here. The slope for the regression line is this, r times the SD of y times that, or over the SD of x. And number 8, the scatter diagram with which of the following would indicate that regression is not appropriate. Select all that apply. If it has outliers, you don't want to do regression. Remember, regression is when it's football shaped or linear shaped. So if it's non-linear shaped, you don't want to do regression. Football shaped is perfect. Linear shaped is perfect. That's what we want in order to be able